Today, we're going to be seeing a demonstration of Infinigraph, Neo4j's graph database architecture for distributed scalability. For the demonstration today, we're using a large cluster of several dozen machines using Infinigraph, and each machine runs a portion or a shard of the database. Now, because Infinigraph is transparent to applications and tools, we can continue to use the same management and query and application tools that we're used to using for non-sharded graphs against a sharded graph. Now, for this demonstration, you can see we have a database with roughly 15 billion nodes and 30 billion relationships. And in the database, it's a fairly straightforward data model of transactions at a financial institution that we might use for fraud detection. And as you can see here, we can write queries the same way that we write queries against a non-sharded graph, and those queries continue to work with Infinigraph, making it very easy to adopt Infinigraph for distributed scale. Now for the demonstration today, let's start a workload where we just generate some new transactions in a loop. And if we monitor the count here, we can see the number of transactions are growing over time. And even while we're running those write transactions, we can run read transactions against the same database. Again, it works just as you expect a Neo4j Graph database to work. Now, the query planner knows that the graph is sharded and automatically constructs the query to work against a sharded database, or automatically plans that query. You as the application developer don't have to make any changes to your application, so you can continue to do things such as detect fraud rings. You can also use the same graph analytics capabilities, in this case running a weakly connected components algorithm against the database to help find those communities of fraudsters. And in our example here, we've projected a graph, we've run an algorithm, we've got some results, and we can take an account associated with one of those communities and run a cipher query, just as we would run a cipher query against a non-sharded database. So Infinigraph is giving us the ability to run large databases and large workloads using a distributed architecture. Now, as I've said, Infinigraph is transparent to our end user applications, so we can continue to use the same tools. In this case, we're looking at Neo4j Explore, which lets us do ad hoc exploration of a graph. Here we've looked at a particular customer account and seeing some transactions, and we're simply exploring those as part of, for example, a fraud analytic application where we're trying to understand, is this account actually committing fraud? Is it something we need to worry about? And so what Infinigraph is doing for us is it's giving us a very transparent, in other words, no changes to our application, way to scale large graphs.